Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by installing Torch and Pytorch Lightning and creating a minimal project layout so you can iterate quickly. Next, prepare your dataset and data loader with a sensible batch size and transforms. This ensures reproducible inputs. Then scaffold a Lightning module file and a trainer script so code is organized. Once done, instantiate the data loaders and verify a single batch passes through. This first run catches shape and D-type mismatches early and lets you move to model implementation confidently. Now implement your Lightning module, define the neural network, loss function, and the optimizer configuration clearly so training logic is encapsulated. In training step and validation step, return losses and use self. Log for metrics that you want tracked. This lets trainer handle logging and checkpointing. Configure optimizers to return optimizer and schedulers if needed, and enable precision or gradient clipping in trainer for stability. Make sure to test a short epoch locally, so you verify backprop and logging behavior. Finally, instantiate the trainer with appropriate GPUs, max epochs, callbacks, and a logger so experiments are reproducible. Run trainer. Fit and then trainer. Test. Save the best checkpoint and export model artifacts for deployment. Monitor metrics and early stopping to avoid overfitting. If training stalls or diverges, check your learning rate, batch normalization behavior, data leakage, and GPU memory usage. One common fix is lowering LR or enabling gradient clipping. Keep small reproducible runs to iterate quickly and fix issues efficiently.
Thanks for watching. Consider subscribing if I helped unscramble your problems.